Hi. We'll continue explaining the synchronous motor. In this video, we're going to explain if you have a constant power in synchronous motor and you vary the excitation. So what is the relationship between the excitation voltage and the angular power? Well, that's the equation of the power developed in the synchronous motor, and it's equal the magnitude of the armature voltage VA and the excitation voltage, the magnitude of excitation voltage EF, synchronous reactance, and sine delta. Delta is the power angle, and PD is the power developed. If we now assume that this is constant, and of course the voltage applied to the armature is constant, XS is constant, so you can say that to have a constant power, you got to keep the magnitude of the excitation voltage EF times sine delta equal constant. So that's the condition for having a constant power. What does it mean? It means if EF is a change, sine delta has to change also in a way that their product is equal to constant value. Well, you might ask, how can you change the excitation voltage EF? The magnitude can be controlled by controlling the field current in the synchronous motor. So we can say that to keep this region constant, we can say that sine delta, in this case, is equal to constant divided by the magnitude of the excitation voltage. In other words, sine delta is inversely proportional with the magnitude of the excitation voltage. So if you have two values, you can say sine delta 2 over sine delta 1 is equal to excitation voltage 1 over excitation voltage 2. Simply, that would be the relationship. All right, let's go ahead and solve an example. In this example here, we have, let's just read the problem. You got 208 voltage Y connected three-phase synchronous motor. And let's just go ahead and start the to draw the equivalent circuit. That's J. Let's find XS. It's 4 ohm per phase, J4. And we need to find the armature voltage VA. It's given 208 voltage, so that's line to line. You divide it by square root of 3. That will give you 120 voltage at angle 0. All right, what else? RA is neglected, so you don't have resistance. That's all. Most of the time, that's the case. At a certain load, the motor takes 7.2 kilowatt. Takes means, or said that the stator is taking, or the armature is taking, or consuming 7.2 kilowatt at 0.8 power factor lag. All right, what else? That's it. So the first part, you are asking to, of course, you expect that the current in the motor will be in this direction. Determine the excitation voltage. What does it mean? Determine the excitation voltage. It means find EF. Okay. So when you think about that, when you want to calculate EF, you got to know the armature voltage is given, XS is given, and IA, but IA is not given. So that's a problem. So we need to find IA. How to find IA? You got to use different equation. So you got to use this information, the power. So you know that the power equal to 3 VA IA cosine phi. The power is given 7.2, so it'll be 7,200 watt. 3 times the voltage, we got it per phase 120. IA, we don't know. Cosine phi, the power factor is equal 0.8. Remember, that's lagging. You can now say that the phi is equal cosine minus 1, 0.8 to get the angle. and that will give you, but this is lagging, so put the negative sign, 36.87 degree. Well, using this equation, we have it here, we can find IA, the magnitude. So the magnitude of the armature current will be equal to 7,200 divided by 3 times 120 times 0.8. It will get 25 amp as a magnitude. And we know the angle, so you can express the armature current as a phasor. The magnitude is equal to 25 amp and the angle is equal negative 36.87 degree. So you got the armature current, magnitude and angle, complete information. So, but you want the excitation voltage. Okay, now it's easy. I can use the equivalent circuit and we'll say that the excitation voltage EF is equal VA minus JXSIA. The armature voltage is equal 120 on angle 0 minus J4 times the current. We have the current now 25 and angle negative 36.87 degree. And you evaluate this, I will get EF is equal 100 voltage and the angle is equal to negative 53.13 degree voltage. So that's the excitation voltage, magnitude and angle. But if they ask about excitation voltage, they mean the magnitude, which will be equal to 100 voltage. So that's the first part. Let's continue reading the problem here. 1. If the power developed by the motor remained the same, means constant power, right? Remember that. While the excitation voltage is increased by 50%, excitation voltage increased by 50%. So this EF, we got it be considered as the first case, and EF2 increased by 50%. It means EF2 will be equal 150% of the voltage, the first excitation voltage. So we have 1.5 times 100, and now we have 150 volt. That's the magnitude of the excitation voltage when it's increased. How increased? We say practically increasing by the field current IF. Anyway, so to keep a constant power and you increase EF, remember the relationship we said, you got to keep EF sine delta constant, and that will be the relationship between the delta and EF. So we need to find the new power angle. So I'll say sine delta 2 divided by sine delta 1 is equal the magnitude of the voltage EF1 divided by EF2. So sine delta 2 over sine delta 1. We have delta 1. How we find delta 1? Well, that's EF1 as a phasor. That's the magnitude, 100, and that's the angle, negative 53.13. But when we substitute, we'll just take the absolute value of it. So you have sine 53.13. All right, equal EF1, it's 100 voltage, and EF2 increased to 150. So sine delta 2, you get it. All right, when you solve that, so the value of sine delta 2 will be equal to 0.533, and you find the inverse, so you'll find delta 2 is equal to 32.23 degree. And as we said last time, it's a motor, so this angle should be negative. Positive will be the wrong answer. So we got the new power angle to keep the power constant. So determine the new armature current and the power factor. Armature current, now it's easy. Always the armature current, we use this equation. So now the armature current, just to make it easy for you, I'll just sketch it again. EF2, VA didn't change, and this is the current IA, and that's GA. So IA will be equal VA minus EF, the new one, magnitude and angle, divided by JXS. Now let's just substitute by the values that we have. VA, it's equal to 120 volts, I think. Yeah, 120 volts on angle 0. So equal to 120 on angle 0 minus EF2. EF2, it's 150. And the angle is negative 32.23. And the reactance, it's equal to 4 ohm. And we get the armature current, magnitude and angle, that's equal to 20 and angle 4.92. So that's IA in the second case. All right. Do you need the power factor? It's easy. Power factor will also be cosine the angle of IA, which is cosine 4.92. It's equal 0.996, and it's leading, obviously, because the angle of the current is positive. And that's it. Thank you.